Okay, now they get a little bit more complicated. Write a log expression in expanded form. Write the expression as a sum or difference of logs, and don't leave powers. So make sure you put the powers out front. Number 7, the natural log of quantity a to the 4th times b, all divided by c to the 8th. Okay, first step. I'm going to leave that numerator as a product for now. I'm going to get rid of this. How? I'm going to write it as the natural log of a to the 4th b minus the natural log of c to the 8th. Now take care of the a to the 4th times b. How am I going to split that up and expand it? Natural log of a to the 4th plus the natural log of b minus the natural log of c to the 8th. One more step. What are you going to do to the powers? Put them out front. So your answer as an expanded log would be 4 natural log a plus natural log b minus 8 natural log c. Yes? No?
Maybe so.
Maybe so. Number 8. Log base 5 of the cubed root of the quantity 25 divided by a squared plus b quantity squared. Let's go play with this first. How am I going to play with it? Instead of writing the cubed root, I can write it as 25 to the 1/3 over a squared plus b quantity squared to the 1/3. Everybody with me? All I did was write the 1/3 power here and here. Okay, 25, how can I write that? 5 to the 2? Yep. So I've got 5 squared to the 1/3. Down here, do you see I have a power to a power? What power will that be? To the 2/3. Good. So I have a squared plus b to the 2/3. Same reason, what's up here? 2/3? Okay. I have log base 5 of 5 to the 2/3 over a squared plus b to the 2/3. Now go expand, get rid of the division, expand it, and then move your powers out front. Yes. So how do I get rid of the division here? I do it as subtraction. So I have log base 5 of 5 to the 2/3 minus log base 5 of a squared plus b to the 2/3. What does that simplify to? Just 2/3. If you wanted to do the 2/3 out front, it'd be 2/3 times log base 5 of 5. And what is log base 5 of 5? 1. So my answer is just 2/3 here minus, can I bring that out front? Yep. So I get minus 2/3 log base 5 of a squared plus b. Now over here, Can I expand that any? Somebody just said, mm-mm. Mm-mm. Can I do that as log base 5 of a squared plus log base 5 of b? No. So I just leave it alone. I'm finished with that problem. Yep. Question?
So on the first part, why did we got rid of the log base 5?
Why did I want to write this as a 5 to the 2/3?
The lower part, when you get log 5.
Here?
Yeah.
Why does that go to just 2/3? I can show you two different reasons. Because, whoops, log base b of b to the x is just x. Log base 5 of 5 to the 2/3 is just 2/3, right?
Yeah.
Or you could have seen that as bring the 2/3 down, and 2/3 log base 5 of 5, this is equal to 1. And what is 2/3 times 1? 2/3. Yep. So two different ways to look at that. I like this rule. Write the log as a single log expression. Now you've got it expanded, and you want to condense it and write it as one log. First and foremost, are they all the same base? Yes. So I'm going to write it as log base 3 of something. To squish these two, you see I have a plus between them. So that means to multiply this number and that number. So I'm going to do log base 3 of 54 times 10. I'm viewing it this way, this stuff minus that stuff. How do I get rid of this? I'm going to divide this number by that number. So I have log of 54 times 10 all divided by 20. Now, what is 54 times 10? 540? 540 divided by 20. What's 54 divided by 2? 27. So I have log base 3 of 27. Am I finished? No. 27 is a power of 3. Do you agree? 27 is actually 3 cubed. Yes? So what is log base 3 of 3 cubed? 3. Number 10. I'll let you work for a second. With number 10, you see that there are numbers out front. So let's take care of those first. They need to sprout legs and go back up as exponents. So I'm going to write that as log of x cubed. What base are we working in, by the way?
10.
Base 10. Minus log of y to the 1/3 minus log of z to the 2/3. Now, do you see two minuses there?
Yes.
Since I have a minus, this is going to go into the denominator. And I have a minus here, so this is going to go into the denominator. Another way to view that, if I were to factor a negative out, do you see that this would be a plus? Do you see that? If I factor the negative, because now if I distribute, I get minus this, minus that. Okay, viewing it this way, do you see that both of these things would be in the denominator now? I'm trying to show you there's several different ways to see it. Okay, let's take care of this first. So I'm going to do log of x cubed divided by y to the 1/3. Log of x cubed divided by y to the 1/3. Now I still have minus log of z to the 2/3, yes? Since I have a minus here, this needs to go in the denominator, exactly. So I'm going to say z to the 2/3 and erase that. I didn't leave enough room. I'm going to do this one more step. Log x cubed. Do you see that you have the 3 in the denominator and the exponent on both of them? I can write that as the cubed root of y times z squared. Number 11. How would you write that as 1 ln? First thing I would do is distribute that 1/2. And it would become 3 ln of x plus 2 plus 1/2 ln x minus ln x. Do you see that these are like terms, 1/2 x minus ln x? What is 1/2 of something minus 1 of that same thing? 3 ln of x plus 2. Combining those two like terms leaves me with minus 1/2 ln x. What do I do to the numbers out front? They need to go back up as exponents. So I have ln of x plus 2 cubed minus ln of x to the 1/2. Instead of saying ln minus ln, I can do 1 big ln and when I'm subtracting 2 ln's, instead of subtracting, I can do the quotient of this divided by that. So I'm going to do the ln of x plus 2 cubed over x to the 1/2 If I don't like writing x to the 1/2, I can write that as the square root of x